Hello AP Physics 1, it's Mr. Ng, and I wanted to go over a giancoli example 420. It's another friction example, and this time it goes through the old system of a pulley. So let's go through the problem. Let's call the big box big M and the little box little m. I'm not a huge fan of doing MA and MB just because it just looks like a mess, right? So two boxes are connected by a cord running through a pulley. The coefficient of kinetic friction is zero point 0.2. Awesome. We ignore the mass of the cord and the pulley and the friction of the pulley, which means that the FTs are the same. So FT and Ft are equal. And we wish to find the acceleration of the system, which will have the same magnitude for both boxes. Fine, fine, fine. So we have two systems here, right? We have the box sliding around left and right, and we have the box falling down. So let's do free body diagrams for all of them, for both of them. This is Ft, that's easy. This is mg, okay. This is, I'm going to do a big M, big mg, because look, we're just going to designate A as big M. This is F normal, and then this is the F of friction. So a lot of these things we could solve already. We already know M, so we know mg. mg is just going to be 5 times 9.8, which is 49 newtons. Easy. That means that F normal is 49 newtons, just in a different direction, right? That seems easy enough. That means we already know the friction. Friction is going to be 0.2 times 49 newtons. How do I get that? 0.2 is right here. Friction coefficient, right? Don't forget that friction is equal to the friction coefficient times F normal. And we know that F normal was, let's see, 49 newtons. And then this thing was 0.20. So if you multiply that across, we get 9.8 newtons. Done, done, done. So we already have a lot of these things already basically solved for us. We just need to know FT. FT is kind of going to be connecting the two systems together. So let's do a sum of forces equation. Sum of forces, let's ignore the y because they're going to cancel out. So basically it's going to be Ft minus F of friction is going to be equal to big M times A. Big M as in the bigger mass. Good. Let's solve for Ft. That's my preference. I like to solve for Ft because I know that the Ft is going to stay the same, and it's an easy way to kind of combine the two equations. So that means that F of t is equal to big M A plus the force of friction. Good. Let's do the box going up and down. Let's do the little m, right? Let's call this little m. Little m is 2 kilometers. We have an mg. We have an ft. They're not equal to each other because there is an overall acceleration going down. And we want to know what that acceleration is. So we could still do a sum of forces though. Sum of forces on the y-axis, let's call this sum of forces on the x-axis, is going to equal to mg, little mg, minus ft, right? And that's going to equal to little m times a. And again, I chose mg because that's the direction that it's going in. It just saves us a lot of trouble later on. So let's do the same thing. Let's solve for ft. That means that negative ft is equal to little ma minus little mg. And then let's switch the signs. That means ft is equal to negative ma plus mg, right? Just because that's ugly. And now that looks ugly to me, so I'm just going to do ft is equal to mg plus ma, right? I'm just going to switch them. No, not mg minus ma, minus ma. Okay, so now I have two ft equations. Now let's combine them, right? Combine the equations. So I'm just going to make the two ft things equal to each other, right? So this means that big Ma plus the force of friction is equal to little mg minus little ma. And let's get the a's together because we need to solve for a. So I'm going to move this MA over. So big MA plus little ma is equal to mg minus the force of friction. Let's take the a out. A is big M plus little m is equal to mg minus the force of friction. So now we just have to divide both sides by big M plus little m, big M plus little m. These guys cancel. So we could just plug in. So A is equal to little m times g. That means 2 times g. 2 times 9.8 minus the force of friction. The force of friction we already found to be 9.8 again. 9.8. These are both in newtons. And then we're going to divide that by the sum of the masses. So that's 5 plus 2. So divided by 7. So A is basically 9.8 divided by 7, which is 1.4 meters per second squared. Awesome. That's the worst circle I've ever drawn. But now we know A is equal to 1.4 meters per second squared. Good. How did I do that? Okay, so for these pulley things, the two things that connect them is going to be the tension or the acceleration, right? So solve for one of those things. If it wants acceleration, probably the easiest thing to do is to solve for friction in both the systems. I mean, solve for tension in both the systems. So that's what I did. I solved for tension for both the systems. And then I made them equal to each other. And that's how I combined the two equations. After I combined the two equations, I did some fancy algebra to try to figure out what A is. And then I found A. I know this one looks really hairy, especially if you're not used to doing the math over and over again. The only way to get comfortable is to do a lot of these math problems. Thank you so much for watching. This video was very long, and I really appreciate you as a student. Bye-bye.